Alright, in this video we're going to talk about rational exponents and their connection to radical numbers. So it should say on a previous slide, not in the previous slide, but we saw that square root of 9 is 3. Okay, we already know this. And so I just want to play around with this a little bit. So if we play around, what we see is that, well, square root of 9 is 3, and then similarly, 3 squared is 9. I want to look at this second one and say, okay, well, I know that 3 squared is 9, right? But then, well, maybe I want to isolate the 3. So what would I have to do to it to get an exponent of 1? Well, I think I'd have to do the same thing to both sides. But remembering laws of exponents, I could raise each side to the 1/2 power, because then on the left-hand side, the 1/2 and 2 would multiply to become 1. And so I'd have 3 on the left side, 9 to the 1/2 on the right side. So that is to say, if we look at this closely, 3 is equal to 9 to the 1/2, and square root of 9 is 3. Same thing. So that is to say, if we look here, when I do the square root of 9, I can represent that as 9 to the 1/2 power. Okay? And in general, if we have a natural number n for an exponent, so natural number 1, 2, 3, etc., okay, we can represent this at the nth root of a as a to the 1 over n power. Okay? Now, this is a little interesting because, well, in our previous problems, we saw that, well, we don't have just a, right? We have something like a to the power of m. So then what does that say? Well, let's think about this a little bit. So we have the nth root of a to the m, okay? And then this is a to the m to the 1 over n power, right? And so then laws of exponents, I can multiply those, and I would get m over n, because this is really m over 1. So, oh wow, we get another property. And this is the one that I remember in general, is that the nth root of a to the m is m over n. Okay? And now that we have this connection to exponents, we have all of our properties for exponents for radicals. Okay, we just need to make sure to convert them. Okay, and so we're going to simplify these two problems. I encourage you to pause the video and take a shot and resume the video once you have an answer. So I paused the video and I am claiming that these are the answers. Let's just go through them. So for the first one, 625 to the minus 3/4, well, that is, let's just make it positive. I don't like working with negative exponents, so this is 1 over 625 to the positive 3/4. But then using our definition here, okay, of fractional exponents, so this is going to be, oops, let's try that again. Okay, we're going to have a radical symbol, 625 is going to be underneath it, and then how I remember it is that the 4 in the denominator actually gets stuck in front of the radical, and then we have an exponent of 3 on the whole thing. And the 3 doesn't matter if you have the 3 under the root with the 625, or you can have 3 to the outside. It happens to be that this expression, this way of looking at it, is a little bit easier to work with. Because what you end up with is, if you do the 4th root of 625, again, factor tree, whatever you need to do, you know it ends in 5, so it's divisible by 5, and that ends up being 5 to the 4th, or just 5, and then you cube that, so you get 1 over 125. Okay? For the next one, what I did in my head was, I have a habit of always working with exponents. I don't know why. I don't really work with radicals myself. So I have to use exponent properties, and I distribute this. So this would be 9 to the 3 halves power, and then y to the 3rd after you multiply. And similarly here, this would be y to the 30 over 3, or 10 power. Okay, and so now all I have to do is simplify the y's. That'd be y to the 10th power, and then 9 to the 3 halves, I'm going to write that out as the square root of 9 to the 3rd power. Well, I know the square root of 9 is 3, right? And 3 to the 3rd power is indeed 27y to the 10th. Okay, so just a connection between rational number exponents and radicals. You have to be able to work in both forms and go back between both of them easily. So if this is kind of a sticking point for you, I encourage you just come up with some numbers, or maybe do some practice in Hawks because they have nice numbers. So get some practice in Hawks. Come and see me in Just Ask, and make sure that you get extra practice with this.